Alright, here's video 2, guys. So we're going to start proving these sum difference identities, and the way we're going to start this process is we're going to prove this first, okay, that the cosine of angle alpha minus beta is equal to cosine alpha cosine beta plus sine alpha sine beta. So I don't know if it's going to help, but the way I think about it is cosine. Co means you stick together, right? So the two cosine terms come first, then the sine terms, and if this is a minus, this is a plus. Okay, so might as well put it in here also. If we have the cosine of alpha plus beta, then all that changes in the identity is this plus becomes a minus. Okay, so we'll start with the cosine of the difference is this, and let me get rid of this stuff. Okay, so the way we're going to do this, we've got this picture set up for us. All right, we've got to look, this green angle here is alpha. Okay, it's the unit, it's the unit circle because this point's 1, 0. And so this point right here is cosine alpha sine alpha, right? That's point A. Going all the way over this angle, that's that point. Angle B is in the blue. Excuse me, not angle B, angle beta. The coordinates of this point here, B, are cosine beta, sine beta. All right, and now this yellow angle, this is the difference of angle alpha minus angle beta. Okay, so, and then this dotted yellow line, this is the distance from point A to point B. Okay, I'm going to draw one more thing here, and hopefully it will make sense what I'm trying to do. But so now I want to replicate this angle. All right, I want to do that same angle, but I want to make this blue side, I want to make it right on the x-axis. Okay, so I'm going to say, oh, well, roughly, if I move this down that amount, I've got to move this green line up that same amount. Okay, and I promise you this is going to make some sense what you see what the heck we're doing. But now, let me clean this up a little bit. So let's get rid of this. Let's get rid of this. Okay, now this angle formed by these two purple rays, that is also alpha minus beta. Okay? So that means that this purple dotted distance, right? Let's call that D. Let's call that D. That should equal this yellow dotted distance. Okay? So this distance here, which is D, that should equal this distance here, which is D. And basically that's because these angles, this angle right here, alpha minus beta, is the same as this angle, alpha minus beta. And since it's a unit circle, all these sides, this blue, this green, this blue, this purple, they're all the same length. They're all 1. All right. So I'm gonna go back to blue, and if I want to compute the distance between point A and point B, right? So in other words, the distance between here and here. Well, that's distance formula. That's the square root of the change of the x coordinates plus the change in the y coordinates. Change in x coordinates squared plus the change in y coordinates squared, all square rooted. That's D. All right, what we're going to do to make things a little bit simpler is we're going to solve for D squared. Okay, so the x coordinate here is cosine alpha. The x coordinate here is cosine beta. So D squared is going to equal cos alpha, that's messy, sorry. Cos alpha minus cos beta squared, right? Plus sine alpha minus sine beta squared. And I know this is messy, sorry for that. But again, this right here is the change in the x coordinates. So that's this minus this squared. this right here is a change in the y coordinates, this minus this squared. If we sum them, we get the distance squared. Okay? So now let's do the same thing for this d, right? This point here, geez, I should label that, right? That's kind of important. That point, well, that's going to be the cosine of the angle formed, which is alpha minus beta, and the sine of the angle formed. And let's call that, we got AB, let's call that, that's point C. Okay? So the distance from this point C to this point here is also D. All right, what's nice about this point, we have no variables, it's just numbers. Because we know this is the unit circle, we go straight to the right. Okay, so this D over here, right? We could say that D squared is equal to, same idea, change in x coordinates, so that's cos alpha minus beta minus 1 squared, plus the change in y coordinates, so that's sine alpha minus beta minus 0 squared. Wow, okay, this looks pretty crazy, and it is. Here's an expression for d squared. Here's an expression for d squared. That's this d, which now I actually am getting a little bit annoyed. I want to make this look a little bit better. So this is going to be blue d. Okay, so let's expand them all out, and I'm going to do that down in quadrants 3 and 4. So this expression for d squared, that's going to be cos squared alpha minus 2 cos alpha cos beta plus cosine squared beta plus sine squared alpha minus 2 sine alpha sine beta plus sine squared beta. Okay, so what the heck is that? That's this. If you expand it out, you get this. This, if you expand it out, you get this. All right. Let's look at some things. So look, we've got cosine squared alpha plus sine squared alpha. These turn into 1. Cosine squared beta plus sine squared beta. Those also turn into 1. And then we've got 2 middle terms that have a 2 there. So hopefully you guys will see this, but this actually turns into, let me write this way, 1 plus 1. That's from, these are 1, 1. These are another 1. Minus 2, I'm going to take the 2 out. All right, and when I take the 2 out, I have this, right? Plus this, because they both have a negative 2. So that's cos alpha, cos beta plus sine alpha, sine beta. And wow, this is a little bit interesting because now this expression right here is that. Maybe you see where this is going. Let's write it one more way. This is really 2 minus 2, and then I'm going to just put this parentheses stuff. Okay? That. All right. Purple parts. Purple parts, same idea, so let's expand this out. All right, so we're going to expand out this plus this. All right? Well, that turns into cosine squared alpha minus beta minus 2 cosine alpha minus beta plus 1 plus sine squared alpha minus beta. That's it. All right, because the zero here, right, it's really just this thing that we're squaring. So the expansion of this part is just that. This stuff is the expansion of, this stuff. All right, this simplifies also, right? This is going to be 1. We've got another 1 here, and then we've got this. So this really turns into 1 plus 1 minus 2 cosine alpha minus beta, which is 2 minus 2 cosine alpha minus beta. All right, so we've got the proof now, guys, because look at this, right? 2 minus 2 times something, 2 minus 2 times something. So basically that means that this stuff, which is all that, right, is equal to this stuff. So here, this is our original part here, and this stuff is our original part here. Okay, so we finished the proof, all right? This proof is done now. Okay, now I'm going to scroll down, and I don't know if you're going to be able to see this too well. I apologize for this, but we just proved this part. Okay? Now the only thing you need to change to go from this to this, and it's hard to see, but this is a minus, this is a plus. All you do is you let this b be a negative b. Okay? And so you can take this formula. Okay, this is a negative b. Well, the cosine of negative b, if this is positive b, and beta. If that's positive beta, this is negative beta. Well, the cosine of negative b is the cosine of b. Beta, if this is negative beta, this part stays the same. Okay, here, this sine beta turns into negative sine beta. So if this is a minus a negative, which is a plus, this part turns negative, and you have cosine alpha cosine beta minus sine alpha sine beta. All right, so you can look it up, but that's basically the idea to get this expression. Yeah, and again, sorry you can't read this too well, but basically if that's a plus, this is a minus, and all the other stuff is the same. Okay, so as we go through this, this is the one that we proved formally. To get this, you just let beta equal negative beta, and you plug into here. All right. To get the sine stuff, well, you can make a substitution, right? You can let, where's my mouse? You can let alpha be pi over 2 minus alpha, and so you can follow that along here. So maybe we'll write that out. Maybe it'll make it a little bit easier to see. So you'd have cosine pi over 2 minus alpha cosine beta cosine beta. I'm going to run out of room. Minus, because we're using this equation 2 to prove this one, minus cosine beta. I'll write it down here. Cosine beta. Cosine beta. Shoot, sorry. I don't like where this is going here. Let's do this first. Let's write the steps, and then I think it'll be clearer. So here we're gonna let alpha equal pi over 2 minus alpha. Not infinity. Alpha. Okay, maybe I'll write it out. And so we'll get cosine pi over 2 minus alpha cosine beta. And then, I don't know if you can see it again, but there's a little trick. If you have, cosine pi over 2 minus alpha plus beta, which is what we had. There's the cosine pi over 2 minus alpha. There's the cosine beta. Now, the sine part now becomes pi over 2 minus alpha. And then the second sine part is sine beta. All right? So, see if I can write that a little bit clearer. So that's going to be, where should I write? Sure, I'll write it below. Write it below. So it's going to be minus sine pi over 2 minus alpha sine beta. Okay, well, here's the thing. This is sine alpha, and this is cosine alpha, right? So this really becomes sine alpha cosine beta minus cosine alpha sine beta. Okay, and where's that box? So yeah, sine alpha cosine beta, that's right there. Cosine alpha sine beta, it's right there. And then the last step, so that's 3. Might have room to put 3, yeah. The last step is very similar, like from going from 1 to 2, you just let beta be negative beta. All right, so I'll write that over here. So for 4, for this, you let beta equal negative beta in 3. Okay? So with the sine identities, excuse me, so if you have sine of alpha minus beta, this sign stays the same. And if you have sine alpha first, that goes first. Then cosine alpha comes second, right? So it's always alpha beta in that order, alpha beta, alpha beta. But sine comes first because you're starting with sine. Cosine is second. And the sign here is the same. So for the last one, if you have sine alpha plus beta, it's sine alpha cosine beta. If this is a plus, that stays a plus, and you have the cosine part. Wow, so there are the IDs. We are actually not going to prove, you can look it up if you're interested, but we're not going to prove the tangent ones. You can prove them, but they're a little bit tricky. Not that the ones we were doing weren't. So again, remember, we started with cosine A minus alpha minus beta, which in this case is A and B. Started with that. Made a substitution to get this one. Made a substitution of pi over 2 minus alpha to get the sign difference, and then made a substitution with a negative to get the sign plus. All right, so those are your sum difference identities. Yeah, let's go. I'm gonna go through this page and then stop and make one final video because I think it's getting pretty lengthy. All right, example: use exact values to verify the following statement. So we got to remember the IDs, and we want to show that sine of 60 plus 30 is equal to this. Okay, so let's go back to blue. This is really the sine of 90, right? If we just add 60 and 30. Hopefully, we know that that is 1. And let's verify that. Well, sine 60, that's root 3 over 2. Cosine of 30, that's also root 3 over 2. Cosine 60, that's a half. And sine 30 is a half. So if we take this right side and expand it out, this is going to be 3/4 plus 1/4. Hey, that's going to be 1. So they work in that case. Now if we look at radians, let's see, pi over 3 minus pi over 6. So if I convert to over 6's, this is 2 pi over 6 minus pi over 6. And that's the sine of pi over 6, which is 30, and the sine of 30 is a half. Let's see if this works. Sine pi over 3, so that's 60 degrees. That's going to be root 3 over 2. Again, I really hope you guys are good with your unit circle, because if you're not, you're in big trouble. Cosine pi over 6, it's also root 3 over 2. Cosine pi over 3, that is cosine of 60, which is a half. And sine pi over 6, that's also a half. So in this case, we get 3/4 minus 1/4, which is 2/4. Yikes. 2/4. Okay, sorry guys. 2/4, which is a half. And again, a half, a half. All right, so I'm going to stop there, make a final video, but this is probably the hardest thing that we looked at in a while, is these proofs and all the algebra. So it's okay if it's a little bit confusing, right? It's pretty tough stuff.